Our idea was to preserve the existing part of a building with rooms and cafes and create extremely attractive upper floors to make it area recognizable. The profile is characterized by a broken descending line and a light and transparent structure. Environmental sustainability has been central to the development of this project. In fact, both in terms of construction and functionality, this building is eco-friendly, with vertical gardens on the north elevation.
The commercial spaces on the ground floor have been maintained, while on the first floor a quite big study area is located. It could be used as a co-working zone or just a meeting space for students. Also, there is an exhibition area on the other side of the building. We would like KIA students to present their design projects there, so everyone can see arts and inventions created by students. On the second floor, we want to see a nice restaurant not only with delicious cuisine, cozy atmosphere and other facilities, but also with a lot of daylight and greenery.
A spiral staircase leads us to the last level. There is a chill area with sitting places and a lot of greenery. The rainwater will be used to water the plants, and it will help us to reduce the amount of water needed to maintain the building. The entire top structure of the building holds on top of the beams and columns. We have some different level heights where we use the cross-laminated timber decks, which is also supported by the same timber columns and the beams.
In this section you get a better understanding of the structure of the building. It shows the placement of our standard constructions in the project, as well as the placement of the key junctions that we will go into depth with later on. It's also clarified in this section how we decided to create different floor heights. This was in order to divide the spaces into smaller areas with each of their own function. It was important for us to do this while still having a lot of light and space inside the building.
The key junction number 1 shows the connection between the floor made of precast concrete slabs, concrete wall and glass facade system. For the facade we are using a unicell curtain wall system. It's a timber framing which combines the wood and glass facade. It's fixed all together by steel connectors and screws.
This key junction shows the connection between the green exterior wall and the glass roof. The glazed roof is attached to the timber beams, which is resting on the columns and the existing wall. The green wall system is attached directly onto the existing wall with a special automatic watering system.
In the key junction number 3, you see the roof connection to a timber column. So first of all, the rubber must be mounted first on top of the column, and it's fixed with a double adhesive tape. The rubber must go continuously over the ridge, and then both parts are glued together. After that, the glass is installed and the thermal strips must be placed accordingly. Then the aluminum profiles are mounted between the vertical profiles, and finally the tip of the aluminum profile is mounted on top in order to protect everything from the rainwater.
The foundation is assumed to be formed by 3 beams and pillars in cast in situ reinforced concrete. These are connected decks made of reinforced concrete core and 2 layers of rigid insulation XPS. The element is then completed with vapor barrier and finishing elements. The external masonry is assumed to be made with a precast concrete structure.
Next key junction is quite simple. It demonstrates the connection between timber column, floor and stairs. The construction is stable due to the angle brackets, screws and wooden framing, which supports the stairs.
This node shows the connection between 3 elements: the CLT deck of the addition, the existing precast concrete wall, and the new wood and metal staircase. The floor and the staircase are bound to the load-bearing concrete wall by means of metal elements and screws that guarantee their solidity. The deck has a main structure in C24 wood and is completed by rigid insulation panels, vapor barriers and finishing layers in wood and plaster.